So my first question is, does anybody know who HGST is? Raise your hands. All right, I see some HGST shirts raising their hands. Not too many people know. I'm not going to get into a long, drawn-out history on who HGST is, but we're probably one of the lesser-known $7 billion earning 41,000 person companies on the planet. And a lot of it's because the things that we make are components that go into storage solutions. So I know it's hardware, it's kind of boring. But I'm stoked to be here talking about software because I agree with a lot of the stuff that was presented earlier that Sage talked about in the transformation of infrastructure to meet the demands of new applications. And I think all of us are here because of that, right? You're here to look at ways you can scale storage for your applications. And the topic I'm talking about is a new topic in the industry, specifically the Open Ethernet Drive architecture. Yeah, go ahead and blame me. I'm a marketing guy, and I came up with the darn term. But rather than come up with a code name or something there, I'm more of a practical guy. I'm no longer qualified to be a Unix sysadmin, which is why I'm in marketing. But generally speaking, I like things to be descriptive, and certainly that's what this is. So let's go ahead and get into the discussion a little bit. Before I do, however, you may not know who HGST is. If you don't, we are the makers of arguably the best storage products on the planet. Hard drives, SSDs, PCIe flash, and software that store the world's most valuable data. Now, that world's most valuable data is often in the systems that you deploy, and we're working on things that are arguably larger than a single one of those things I described, and that's part of what I'm going to be talking about here, is things that are a little bit larger than that. All right, and so why am I showing this forward-looking statement? Most of us have mobile phones. If you're out trying to trade Western Digital stock right now, because I'm saying really exciting things, you can do that after the meeting. And I'm going to give you a lot of forward-looking statements here. Things about the future, cool things that we're working with InkTank on to bring to market. Naturally, you can't expect me to have to come back to you and tell you everything else we've to update you, so that's what a forward-looking statement is. So the easiest way to fix that, just follow us on Twitter, follow us on LinkedIn, and you'll get all the updates, and everything's good to go. And you can buy some stock later. All right. Let me go ahead and get rid of that just for a second. What's this slide supposed to mean? Data creation is accelerating. I don't think anybody disputes that, right? Is it fair to say that you'd reasonably agree with the statement that data doubles approximately every 2 years? Anybody have a problem with that statement? If not, let's say every 3 years. Everyone's cool, right? Do you ever think the number of IT people managing infrastructure will ever double again? So okay, there you go. All of us who went to school and studied math, something's not lining up there, right? So clearly, there needs to be some new technological innovations. And I like to think of the high jump. And I do that because I'm a 5'6", 200-pound guy, and I like to imagine myself high jumping. What happened in the first 50 years of the high jump in the Olympics? Anybody know? The world record steadily increased to a rate of about 15% improvement in the world record over 50 years. Then some dude decided to jump over the bar a different way, called the Fosbury flop, and in 1 year, 15% was added to the world record. In the time since the Fosbury flop, 50 more years, guess how many percentage points improvement there have been on the world record? 15%. All right, doing it the old way, you could reasonably expect to squeeze 15% out of it about every 50 years, or a very small amount of incremental upside. Do things a little bit different, and you can get a really big impact right away. So that's why I'm passionate about Ceph. I got some other stickers up here. If you see me, I'm at SwiftMario on Twitter. Used to work at SwiftStack, so I really love this stuff. Why? Because these data, the data here is telling us we need to do something a little bit different. So why is HGST interested in this at all? Well, if you think about what type of data is being created, the people who use our infrastructure are telling us you can't just put it on tape and stick it away forever, because part of the value of that data is being able to get access to it. And I've done lots of tape backups in the past. I mean, you can see I was an early Veritas user in the day. NDMP just didn't work, right? So I lost my hair doing that stuff. Not that that goes away. It's just that a lot of the things you want to store, you want to be able to access in seconds, not hours or days. Now, we at HGST make the fastest PCI flash cards on the planet too, if you want to access it super, super quick. See my buddies there in the back if you want to talk about that. The reality is, though, for the data pyramid, there's some amount of it in the middle toward the bottom that was probably stuff that you wouldn't think you need to readily access, or, according to this, you didn't even store. Think about the bits that are created today. Sensor data, log data, all the video imagery, all that sort of stuff. How much of that stuff's actually being saved? Not a lot. But if you build a really cool Ceph cluster, you'll have a better chance at saving a lot of that stuff. So anyway, analytics, compliance, I'm not going to ask for a show of hands there, but I imagine most every company's looking at those sort of initiatives. So how do we store more data in a more effective way? I think you get there by having more affordable disk media solutions that can offer you better price capacity, price density, all that sort of stuff. It's not that you want to spend less, it's just you want to get more out of what you're spending. And software-defined storage helps do that. All right, so let's go ahead and break down the language here. Do we have any native French, Spanish, or other romantic language speakers? Anyone? Okay, we have a couple back there. You may look at this and say that the noun is either open or Ethernet. But in Gaelic languages like English that we speak, the noun is architecture, right? But as tech people, we look at that and we're like, ooh, it's got to be about Ethernet. It must be Ethernet. Ethernet's cool. It's got to be Ethernet. Well, this happens to have Ethernet as a descriptor, but the noun is architecture as a building block for the software-defined data center. So what does HGST do? We are the best makers of these storage building blocks, and think of this architecture as a larger storage building block. The same way you would look at a Intel server jammed full of a bunch of SAS drives today, that is a node, right? And you think of that as a unit of measure. Think of this architecture now as being a unit of measure, providing some new cool capabilities. And to look at some of the other descriptors, they wouldn't have invited me here if it wasn't open. I think Sage personally blocks people at the door if you're not into the open thing, right? And Ethernet happens to be what people geek out about. I'll describe that here in a second. And drive, yes, that's what we do at HGST. We make drives. But think of it as a foundational building block for the software-defined data center. All right, do you want a vendor-specific API, people? What if I told you, hey, you know what? I've got some really cool stuff. Here's my API. You want some of that? Well, unless it was really, really awesome, which is hardly ever. But even at that, right? Even that, you're thinking, yeah, I've got tickets to the Red Sox game, but I have to walk 5 miles in the rain. I don't know. Are you that hardcore? You'd walk 5 miles in the rain? Maybe you would. Maybe that's a bad analogy. But there comes some point where something's really cool, but you're like, it's not worth it, right? So our view is you can't scale out if you really have a vendor-specific API, because it's just never going to be there. I put an API out. You guys want to innovate. I have to up-rev the API. The limitations just doesn't work. Why don't we give you something open? So that's why I'm so stoked about this. We're going to go a little Mission Impossible. I had to do this because we're going to go straight down to the CLI in the demo, and I want to create some contrast, right? That's where I'm going to get my biggest oohs and ahs when we're like partying on the hard drive, CLI style. How are we going to party on the hard drive at the CLI? It's because we have open software and hardware. It's part of our Open Ethernet drive architecture. And I think in our demo you'll see we have the concept that if you take services that would be distributed in an Intel node architecture and move some of those services closer to the drive itself, there's an opportunity to do some cool things. I think everybody knows that now. It's on us to prove that it's actually cool. And I'll tell you a little bit more about those developments here. But we want to distribute those services across the infrastructure as close to the drive media as you can. How do we do that, you might ask? I'll let you look at that and think about it for a second. Anybody heard of Debian before? That's what you get. Debian, we have an Ethernet driver. We wrote, of course, it's open source. You can do whatever you want to it, but just to help you get access to the Ethernet ports on the drive. It looks like EHT0, so you can do UDP, TCP, AOE, any E's you want, right? It's open source. Do whatever the heck you want. Secondly, to get access to the drive and CPU, you already know how to use the drive and the CPU and the memory that's on the drive because it's a open Linux environment. You can do what you want, which is why I'm trying to coin the phrase party on the hard drive. They're not liking that too much. Anyway, and the drive happens to have Ethernet connectivity, and I'll show you how that comes to fruit here in a second. But the idea here is that it's like a microserver. I don't want to call it a microserver because then everybody's going to have hackathons and put like sorts of wacky stuff on it. At the end of the day, when people say, I ask them, hey, what is it that you really want most out of your storage system? They say, I want really, really scalable, good performance, and less expensive. Or I say, great, which one do you want to give up? Well, if I push real hard, it's the low cost which wins every time. And I think that's part of our being successful with these software-defined storage solutions is really redefining how much these darn things cost. So if I were to put the biggest, baddest processor on the planet on there, it defeats the purpose. If I put a modest infrastructure there that allows you to run a modest set of services that keeps one hard drive spindle busy, that helps do peer-to-peer communications between multiple little microserver nodes, there could be some really cool things going on there. So this does not eliminate the need for CPUs at all. In fact, if you add erasure coding, what happens to your need for CPUs in an environment? Work with me, people. Vocalize. It goes up, right? So there are opportunities to distribute things to better distribute the load. That's kind of what we're thinking about here as far as this architecture. So it runs Linux. You get to do what you want with the CPU and the memory, and it connects via Ethernet. Here's the reason why we want to connect it via Ethernet is, and I had a good discussion with a couple of gentlemen here. I won't out them. We'll protect the names to withhold the names to protect the innocent, that is. They said, hey, we're kind of we're the glue that glues everybody together, but when we bring these tested solutions to folks, the storage people would say, oh, I can't manage that. That's not my thing. It's not a storage array. It's not from the vendor I buy storage from. Hey, I can't manage that. And the servers guys, well, I can't do that either because that's not my area. The reality is, if it connects via Ethernet, the hope is it looks a lot like a server and connects like a server and can be managed using the same management tools that you have today. So there's no need for special monitoring software. If you want to monitor a Linux box, what do you do today? You put some stuff on it and you run it. Cool, that's what you do. You want to check out what your network's doing? You already know how to do that sort of stuff. So the message around Ethernet is it's the easiest connectivity possible. Plus a lot of the apps that we're doing are using RESTful APIs all the way down the Ethernet route. So who's with me so far? Cool? All right, I'm going to do a quick check to see if my friend has joined. Participants. The participants are not actors. This is a live fire exercise. Okay, I'm going to start to perspire a little bit here only because my friend's not on, but give it another second. I got some more slides. No, I've got some more slides. I'm just trying to do that so you connect with me emotionally. I'm a hugger, what can I say? So let's show you a little bit about what the hardware looks like exactly, because people always ask, whoa, that looks cool. What does it look like? What does it look like to you? Kind of boring, like a hard drive. In fact, it looks like a 3.5-inch hard drive. The SAS connector's in the same darn spot. It's a SAS connector, which happens to have pins that carry multiple signals. For us, we can use those pins for different things. We have a system-on-chip design with the Ethernet built into the SoC, and we've expanded the ARM processor footprint that's on every hard drive. Quiz. How many ARM processors are there on a normal hard drive? Anybody? 0, 1, 2? The answer is 1. All right. A couple people. Free sticker over in the back for anybody. By the way, I'm going to plug, we have a prize back there. We have something that looks a lot like a hard drive back there for your personal use. Back your stuff up. You know you need to. Make sure you stop by and see Kem there at the back. Throw your card in the fishbowl, and we will randomly select a lucky winner. This is a 3.5-inch hard drive. We chose a 4 terabyte one. So people ask me, hey, Mario, can I get this in an SSD? Why? Mostly because I think it's just really cool. Wouldn't it be really cool to have an SSD with a Linux head and I can do all sorts of stuff? We've chosen to do a 4 terabyte drive, and here's why. A lot of the feedback that we've gotten is that these scale-out clusters tend to be more capacity-oriented, and that at the lowest level of the storage tier in a scale-out cluster, your capacity and price capacity is what people are looking for. That being said, this design where we have an additional ARM, so 2 ARMs on there, additional DRAM and the Ethernet built in, it's something that can be applied to any drive technology that we have. And people ask me, hey, Mari, when can I go buy one of these things? The answer is, we will productize it when we get that killer combination of a killer application with the architecture. The reason is, while this is cool, you might put it in your lab, play with it for a while, but like a lot of those cool toys that your kids play with and they just simply don't use ever again, you know, we don't want to be one of those. In fact, when we know that it's something that you're going to use every day because the app's just truly killer and the software is optimized to run on it, that's when you expect to see it in the marketplace. And I'll talk a little bit more about some of the milestones here in the future. But something that's not for sale, but we're talking about it. My guess is you're stimulated, because most people who hear this, they're stimulated, right? Woohoo, this is cool. They like this sort of stuff. Ethernet connectivity, integrated SoC, minimal cost uplift for us, because if it wasn't affordable, it's something you couldn't deploy. And this is how we do it. We do it in a very efficient way. Now, I thought I heard myself say it was Ethernet, and here's how. We take the drive, and we put it into an enclosure which holds hard drives the way an industry standard server would hold lots of hard drives. This particular reference design, because it has 60 slots and some power supplies in the back, they go in dishwasher style. For you reference design, 60 drives in there, 240 terabytes at a 4 terabyte drive. It has an embedded switch fabric. So this is more like a blade server than it is a storage enclosure, in the sense that you have a blade server that have a bunch of nodes in it, and there'd be an integrated top-of-rack switch in the blade server. You can think of it like this. And so we have 2 of those back there. The rendering here only has 2 ports on the back, but actually our reference design has 8 ports of 10 gig on the back side. So 60 drives that have gigabit Ethernet in the inside, 8 10 gigs on the outside. Now, is this the final configuration? Naturally not. We need to figure out the right perfect recipe in order to make this work. But what it allows us to do is test at scale a lot of these solutions, really test it at scale versus a single little dongle adapter on the back of one drive. That's kind of cool. You'll play with that for a little bit and throw that away. Here, we can actually test it out in a really large, meaningful fashion. The devices look like Linux servers on your network. So here's some photographic evidence, a little too heavy for the overhead bin on the flight over. But yeah, the dishes go in, hello. The drives go in, they both start with D, go up and down inside that way. We have some photos of the stuff that was there. And so did anybody go to the OpenStack Summit in Atlanta? All right, cool. A lot of the Red Hat and InkTank folks did. So we had a lot of folks coming by because whatever is flashing lights and real running hardware draws people. And the sound of the fans too, I think. Which meanwhile, we have some demos back there. Anybody see the demo back there yet? Make sure you do that before you leave. All right, I'll get my 20 bucks later. All right, speaking of 20 bucks, I'm going to have to, let me see if my buddy is here. No. Hey, somebody call Car and Beer. Look him up online and give him a call. No worries, though. I've got more stuff. Which we should just play the George Carlin video right now. That would be perfect. If you haven't, go to YouTube, George Carlin stuff. It's an epic bit. Absolutely epic. All right. So what kind of stuff do we have running today? And really, our coming out party for this technology was the OpenStack Summit. Previously, heck, nobody even knew who HGST was by and large, and they certainly didn't know that we're doing some cool things around open source. So what we did, because we didn't have to ask anybody's permission, we just simply went to GitHub and grabbed some stuff, compiled it for our ARM processor, and threw it on the box. And what we found is some pretty cool stuff. We naturally can run Ceph, and we run each drive as its own OSD, and a couple of them as monitors and OSDs, just to kind of show that it's flexible. That's a Linux environment. And go ahead and queue up your favorite commands, because we're going to go full live demo unplugged and let you shout out commands that we'll type in and actually see what happens there. We also took the bricks stuff from Gluster and threw it on there and found that runs pretty well too. OpenStack runs, and our demo that we show, our live demo of the Ceph stuff, will actually use the OpenStack API to do some of the data transfer stuff there to show you that it's all coolness as far as that stuff goes. Now, let me go back to the demo time. We'll give them like 2 more minutes to join. We're radically ahead of schedule. I think that's one of the things that's blocking us here. But really the goal of our technology demonstration was to work with cloud software engineers on these new building blocks for the data center of the future. Now, I assume you guys all paid money to come here because you believe this software-defined stuff really does have a role in the data center of the future, right? So what's going to stop us? Anybody? Let's get philosophical up in here. What's going to stop us from being successful in this, in using these scale-out, open source sort of software storage solutions?
You doing a live demo?
I will be doing. Oh, yeah, that's the live demo is going to work. I need my buddy on the other side to get it run up. A lot of people have told us that having more commercial support for it. The idea that, hey, you're the mad scientist and you're creating these really cool solutions for new applications, but it's hard to then assimilate those maybe into the mainstream. And that with folks like Red Hat, who've made arguably the best business there is on providing enterprise support for open source, and now that applying to InkTank and other large companies like HP and HGST getting behind it, our hope is that can really help make it a lot more consumable as well. So, marketing statement up the top. Yeah, you can move data-centric services as close as possible. Did anybody think analytics in the stuff that I present? Did you think, whoa, a processor down there, maybe I can ship some little SETI-like code to go down there and check something out and give me some answers back? I don't know. I used to have a big net backup environment, worked for a storage service provider, which got a lot of money and then went out of business like we all did. And we ran SETI. We got to the top, like 1/10 of 1% of contributors back then because we weren't using the servers for anything else. But I've always been fascinated with that idea that we have all this big data, and what if we could ship more of the processing closer to where the data is so we can eliminate some of that traffic back and forth? Because as was discussed earlier, that traffic in the back by Mellanox, that back-end network gets pretty busy in a lot of these clusters. So maybe there's a way we can send less across there as an opportunity in some of this. But that's been some of the use cases that folks have been talking about. Did I bring any more slides? Let's go ahead and do this then. Anybody read that Facebook paper that was done? A lot of people have. And I think what it was is that in scale-out solutions, you design for failure. You expect there to be failures, but when it rains, it pours, and there's always there's more failures at the same time than you would have expected, quite honestly. And it's one of those tough things to plan for. And one of the things about production systems, if you plan for 50% of your capacity being out, you're going to be radically over-provisioned. So you're trying to find that sweet spot there in the middle. And one of the things that the HGST research team has been looking at doing is really understanding the role that drives play, and then understanding the role in new durability schemes for storage. Because I think everybody agrees, RAID is awesome. I worked back at Adaptec back in the 90s when we had RAID on motherboard. That stuff was really cool, but you can't create 100 petabyte RAID sets anymore. So the technologies need to change in how we really survive from those scale-out solutions and have data recovery there. Here's what's going on in terms of the traffic. If you design for failure, you really want to try to minimize the amount of impact that a failure has. So this paper did talk a lot about how lots of things happen while it's trying to go through and recover itself. So the method in which you do your erasure coding can benefit that. And some of the feedback we've gotten is that, because we're a hard drive company, right? You think we'd love replicas, like, woohoo, replicas all day long, 3, 4, 5. That's awesome, right? Because you use a lot more hard drives, right? But the reality is you're not going to spend any more or less money. You're always going to spend everything you got, right? You just want to use as much as possible. So for us, we're thinking, okay, great. That means you'll have just net more usable. You'll still buy all the same stuff. You'll just get a lot more net usable if you use erasure codes. How many of you are thinking about erasure codes in the future? It's not for every application, right? Some applications benefit real greatly from replicas, others, from erasure code. So we see, at least in the scale out, in the archiving, in the long tail data, in backup as a service, and some of those other sort of use cases that people are talking to us about, that erasure code is going to be really popular. So our folks in the HGST Research Lab are actually doing some things to contribute back to the Ceph community. So one of them, we're working on some erasure coding approaches that actually can recover from 2 failures, but at the same time, they use standard row parity for efficiency. So we're not changing that. We're also looking at leveraging XOR functions that would beat there. So as you're doing software-defined stuff, you're not incurring any extra stuff you might otherwise be doing as a part of doing that. And where it really comes in is optimizing the bandwidth and access ratios for recovery. Because you can design for no failures, you want to minimize that for failures. Because I've even talked to a lot of object storage companies, folks that buy product from HGST, and one of their biggest challenges is telling customers how to deploy all their stuff so any number of combinations of failures wouldn't result in too much hardship on the solution. It's really hard to do when your unit of measure is 3 nodes. And even harder if you have, let's say, 20 nodes, but you have 20 nodes, 2 data centers, 4 rows each, and where do you put what where, and how aggressive can you go with your erasure coding? So we're looking at ways to reduce the data read by 50% or cut it in half, as well as when you go to access it, you only have to access 1 bit of data versus 2, so 50% reduction in that if you only had 1 erasure. These are things that we fully would aim to contribute to the open source community. The reason I can't give you any more information is because we want to make sure that we get all that stuff legally signed off before we do it. But we have some smart folks working on this stuff because Parkinson's law probably is true. Successful solutions will scale to meet the capacity of that solution. It's just going to happen. So if we can give you a lot more capacity, you're going to be able to do a lot more with it. And if you can do a lot more with the same, that's what our bosses, I think, try to pay us on. And whether we show up and work on time. But hey, a lot of that stuff you can do from your home, VPN in. All right, want to learn more about this sort of stuff? You can contact me. I'll be hanging around a little bit later. Now we'll see if somebody's there. Still nobody's there. All right. Was anybody able to call him? Karanveer with a K. Karanveer with a K. Yes, while we try to connect it. All right. Request permission to show you a very brief commercial. I got the microphone, so I guess I can do what I want. Here's my last slide before we get into the live demo, and hopefully he jumps on here real quick. So we're definitely happy to take a growing role in the Ceph community. We've done a couple doc contributions today. Those are always easy. But part of that is so our engineering team can get ramped up on it. We're also exploring the optimization of Ceph services to run as close to the drive media as possible. That's the open Ethernet drive stuff. How can we give you that as an option, which truly scales that stuff out? And if you've got an idea on how you could even use that for some of your own code, fantastic. I'd love to hear your ideas there. And solutions for software-defined scale-out storage is something we're working on. Has anybody heard of Helium?
What's the meeting ID? He's on. He's not able to join.
Okay. Gotta love that. Let me. All right, you guys are seeing the sausage being made live. Now he's on. Okay. Remember the days of pagers when you paged somebody, we're thinking, hey, did they get my page? Did they get my page? Nowadays, you can see whether or not your SMS went through, delivered or not. So whether they're looking at the phone, though, is a different thing. All right, while we go ahead and get that set up, in fact, I'll transfer ownership over to him. Let me change role to presenter. All right, so coming to you live from the mile-high city of Denver is Karanveer Singh, a colleague of mine. He helped me do these demos at the OpenStack Summit. I will actually stop sharing. I guess I should stop sharing. Anybody have any questions? Well, yes, a question right there.
So this new technology that you're working on sounds a lot like local recovery codes, but it's different?
Local recovery codes in the sense of the way the erasure coding.
Use less data to recover from one single drive failure. I assume that's what you meant, and not one erasure, because I don't think that's a thing.
Yeah.
But this is actually different from local recovery code?
Different than local recovery because it's an erasure coding approach. So an actual algorithm different than the standard ones that you might use. So think of it as a
alternative to the erasure encoding that is going to be built into, or that is built into Ceph.
yes, as an option, and just put it up there because it's all about choice, right? There's different use cases for different types of solutions. So let's hopefully Karanveer can pump up his thing. Hey, Karanveer, can you hear me? If you can, pump up the size of your display. Actually, Karanveer, if you can pump up the size of your display, that'd be great. And am I optimally resolved here? Hopefully I am. Hey, so can you hear me, Karanveer?
I can hear you.
He can hear me now. Good. All right. Pump up the size of your display if you don't mind. I'm going to grab my notes. All right, drum roll, please. It's party on the hard drive, people. We're going to show some live demo stuff here. I'm going to grab some notes to make sure I don't miss any of my key points. All right, so that's the HGST website. That's Cisco WebEx. And what the heck is this? This is a bit of code that we took. It's based on Mirantis Fuel, ripped it down, threw together a quick visualization. We were going to the OpenStack Summit. We figured, heck, we might want to just use CLI only, but you got a bunch of press and analyst folks there. They got to see something that looks like a GUI. So we threw together a GUI here, which shows that we're in the same environment running an OpenStack environment, a Ceph cluster, and a Gluster cluster. Is Gluster cluster a real word? Say that 10 times fast. Gluster cluster, didn't do it. The cool thing about this is because it's the same code that runs on Intel nodes, just compiled for that ARM and running there, you can mix and match all this cool hard drive technology with existing nodes today. That makes it pretty cool. Now, as we drill into it, we'll see that we have this is our Ceph nodes or Ceph cluster here. We've got an Intel server running our Rados gateway, and monitor there. If I look at that, you'll see that it has two VLANs. So you really need your glasses for that, or the resolution not looking so good. You'll trust me when it says 106 and 107 as my two VLANs that are there. One, the back side, one the front side. We do have 3 of our Open Ethernet drives that are deployed here. So these two have the storage and monitor on it. The other one just has the OSD. You have IP addresses for each one of those, and we'll drill into each of those and show you kind of how they work. The next thing we want to do is we want to go into a client machine. It's just a standard box, a Linux box itself, and we're going to go through the VLAN and just show the networking that are, that is the client machine. Thanks. Hey, Karanveer, if you can hear me, if you can just increase that text at all, that'd be super helpful. All right, I need more cowbell. There you go. That's probably good. We good now? Great. Yeah, if you can center the box a little bit, Karanveer. We have a picky crowd here today. It's high maintenance. Say again? No, I guess for right now, you show the networking. No, I think it looks fine. But if you can move the window over just to the right, just the whole window just a little bit, that'd be helpful.
Okay.
Yes. Are we cool there? Hopefully we're cool. All right, so go ahead and if config it out and see what we get. Boom, yeah, it's pretty big, so you'll go ahead and drop that down. But generally speaking, what we want to show you that we can show the network topology here, and what do we notice? That we've got that VLAN out there that's going to that side of the network, the external part of the network. And if you go back and look at that, yeah, it matches that one VLAN out there. So, what do you say we start moving some data? So we're going to actually use some OpenStack APIs to move some data across. That's what's so cool about Ceph. Do you know what the number 2 used block storage driver in all of OpenStack is? You got to get motivated about that. It's Ceph, people. No one would have thought that, right? They're like, whoa, number 2? Number 2. Totally popular. All right, so rocking it out OpenStack style, you'll see that we've done a command there using the RESTful API. Let's go ahead and upload a file to that particular node, if you will. 105 or 1.5 is one of our nodes. So we're going to dump a big file up there. Takes a little bit of a second. All right, and we should see that it moves some stuff pretty well. Big file is in the house now. So you can check to see if it's there. Naturally, you'd expect it would be there. You can remove it. You can do that sort of stuff as far as that stuff goes. So what he's going to do now is he's going to go ahead and download that. And you'll see here that, yeah, like you'd reasonably expect, compare it. Now, hopefully you're not too stimulated by this, because the reality is it's the most basic elementary of stuff. But what it's showing you is that just for fun, we downloaded some stuff, we compiled it, threw it on there, and it's working really, really well. So that concludes kind of some of the stuff we're going to do to move things around. But let's go ahead and go back to the gateway itself. I'm interested in going back there and showing its config, of the monitors and the OSDs, so you can see what's going on there. He's going to show you what IP address that bad boy is. What do you say it was? He's going to go ahead and just SSH over to that guy. And assuming you type the password well, he's now there. See, I forecasted that, didn't I? All right, so he's there. That's an Intel node as we described. It's not the Rados gateway is a full-blown Intel server. And if we now go show us like the monitors and the OSDs. We see here that, yeah, what's there, we can see, yeah, the different IP addresses and stuff. All right, no smoke and mirrors so far. What he's going to show us now, though, is that we have an Ethernet interface on one of the drives themselves. And let's go ahead and go down to one of those and see that. So you'll see it's got its VLANs. What's its IP address there? Do we see it? Oh, he saw it. We'll see it's here soon. SSH into that guy. All right. So if we look at the drive itself, the drive will show that we are running, an ARM7 chip, which is the processor that's on that drive. You'll see that we've got, Ethernet connectivity set up. We can also show some of the processes that are running on the box. When I say box, I think of it as a box. That box is a little drive with a system on chip and ARM7 on it. So you'll see we're running those particular services. So on that monitor, OSD. Now, this may not be the optimal way to deploy it. We're going to be working with some of the folks over at InkTank to do some hackathoning and some other stuff to see how to even better do it. But this is just us having fun, grabbing the stuff down and deploying it on the drive. So just so everybody knows, this is a little bitty 3.5-inch hard drive running Linux, thinking that it's a big bad OSD.
Can you tell us how much RAM is in there?
The question is, can you tell us how much RAM is in there? What command would I run to tell me how much RAM's in there?
Free.
Type in free. Come on now, people, give me another command.
Cat proxy view info.
Cat proxy. There you go. I told you it was Linux. It's cool, huh? Hey, so you know what? People might want to think that we're, like do an IP link. I like that. Maybe I'm telling you the wrong thing.
No, it's not a Linux.
So we can show you that how the Ethernet interfaces work a little bit more as far as that goes. Hey, how about LSMod? Anybody want to see what that looks like?
You already did it. There's nothing in there.
Okay, cool. No modules, so no foreign modules. You want to put some there? Go for it. That's cool stuff for you to do. Yes, there was a question.
The reference design, on the back of your chassis, the 60-drive chassis, had 2 switches, which I guess are for redundancy.
Yeah.
How does it reach the drive? Doesn't it has 2 interfaces, like bonding or bridge?
That's a fantastic question. So the question was, very observant, 2 switch fabric modules in the back of the chassis. How does it provide redundancy inside the system? Today, for our development, we have a single Ethernet port on the demo drive. Whether or not it makes sense to take both of those and run them teamed, take one and run them to different networks, a lot of that's going to be an implementation decision that we want to make in cooperation with a software partner to find out the best way to run it. If you think about what this would replace, it's a SAS adapter connected to a disk, which in many cases is just one connection designed for failure type of environment. So we kind of wanted to mimic that from a behavior and a cost perspective to start, but we're not limited by the design in that way. We put the chassis together just because it was a commercially off the price list available chassis, which happened to come with 2 switch modules in it for now. So that was a very observant thing. Put an extra business card in there. You'll increase your chances of winning a hard drive. I got nothing to give you, though. Actually, I take it back. I got a sticker if you want a sticker. Other Linux commands. Anybody got a Linux command for car and veer? We got another question, though.
Is the OS embedded on the drive, or is it a separate area from the OS?
Fantastic. Is the OS embedded on the drive, or is there a separate area? It's our plan that you would put this into the chassis, and it would TFTP boot from the enclosure itself and get the base image, to which then you have now the base Debian image. You can then, from there, do whatever you want. So it's our belief that while, I guess some people ask, hey, can I get a different version of Linux on that? Yeah, sure, let's work with some software developers. But generally speaking, what we want to provide flexibility for is any software that run in a Linux environment. It may be kind of hard for us to support every version under the sun. I mean, you'll see we've got what's probably the latest stable version of Debian up there right now, and we're working on the next version in our labs as well. Question?
If you have to replace the drive, does the new drive have a new IP address?
Fantastic question. If you have to replace a drive, does a new drive have a new IP address? How do you want it to work?
Roughly the same.
Cool. Yeah, the idea is that we would want to give the flexibility to the developer. If there's anything you leave from this presentation, folks, other than that loud guy from California, it's that this is an open platform. We want you to do what you want to do with it, because that's the way that the best creative solutions are going to be created. We're not going to give you a key value API that's only limited to one thing. You can put anything you want on it. But of course, it would have a different MAC address, and you'd have to manage that. But a lot of people would say, is 60 drives behind one switch? Oh, that looks weird. That's too many devices to manage. Well, you guys know how to manage IP addresses, right? It's a Linux environment. Do what you want. You can firewall, you can load balance, you can do all sorts of other wacky stuff from a network perspective. Ethernet is Ethernet, and if you don't like the Ethernets on there, it's open source. Put some more Ethernet on there. Another question.
I think maybe this guy over here actually had a slightly different question, because it seems to me as well, which is what I assumed he was talking about, it would seem to make sense for there to be a little bit of flash on a hard drive like this.
Yes.
So you could run the OS of the hard drive on that flash and then access will the hard drive have access to its own storage? Separate from the storage platter that is on the hard drive? I would think it would make sense for their...
Yes. So the answer to that question, I guess, if you didn't hear the question, hey, will it have flash that's separate from its own internal storage, because it makes sense to run the OS from flash? And a lot of people would say in a hybrid drive scenario, it'd be really cool to be able to make a bunch of RAM disks and do a bunch of other crazy stuff there as well. Our view is, if we work with the folks at InkTank and they come up with a killer recipe that uses one of our hybrid drives, great. Slap that board on a hybrid drive and that becomes a really killer solution. We're not married to the specific drive itself. And the second most universally said thing after someone sees this, the first one's always, hey, put that on an SSD and it'll be awesome. The second thing is, put it on a hybrid drive. That way I can create a bunch of cool RAM disks and do all sorts of other crazy stuff. That being said, it is a microserver. So then we got to figure out from a creativity perspective. Anyway, hopefully I haven't sold past the close, people. It's open. You get to do what you want. What's it good for? That's why we're out here talking to you guys, because we want to know what kind of use cases you might see. We want to see how it adds value, and the best way to do that is actually do some testing and such, and the best way to do that is work with the smartest of the software folks out there, which is why we're very happy to be having been invited to here at Ceph Day. Can I get a round of applause for Karanveer Singh, live from Denver, folks? He said sorry he was late. All right. Hey, thanks, Karanveer. All right. So it was live enough. We screwed it up enough. Clearly, if that wasn't live, we really did a bad job, because nothing would have been that good. I have my arigato gozaimashita slide to thank you very much for your time. I think we're going to do the panel, and you can hit me with more questions then, but it's been a lot of fun, folks, and I look forward to chatting with you. Don't forget, enter the drawing and come talk to my guys over at HGST. All right.